Welcome to Knowledge Base. We have a question here under velocity time graph. It says a bus moves from rest with a uniform acceleration of 2 meters per second square for the first 10 seconds. It continues at a uniform speed for 70 seconds and finally comes to rest in 20 seconds by uniform deceleration. Draw the velocity time graph of the motion. So we have this question and we are just going to draw the velocity time graph of this motion. If you are coming across our video for the first time, please endeavor to click on the follow button and watch this video to the end. You will benefit from it. So we take the question gradually. It says a bus moves from rest with a uniform acceleration of 2 meters per second square for the first 10 seconds. In velocity time graph, this is what we have as the graph. The graph of velocity on the vertical axis plotted against time on the horizontal axis. And the first part of the journey says acceleration of 2 meters per second square for the first 10 seconds, beginning from rest. And this is how it looks like. Beginning from rest A, it accelerates to a point B at the rate of 2 meters per second square for a time of what? 10 seconds. So this is a representation of the acceleration phase. It says it continues at a uniform speed for 70 seconds. It means when it got to the speed of B, it maintained that speed for 70 seconds. And that's what we have. It maintained this speed for what? For 70 seconds. So this is the uniform speed stage of the journey. Then we are told that and finally comes to rest in 20 seconds. It means it took 20 seconds for it to decelerate to rest. 20 seconds. So it comes to rest in 20 seconds by uniform deceleration. So there is a uniform deceleration that happens for 20 seconds. So this is the velocity time graph of the motion. It's as simple as that. Now let's consider these questions under this velocity time graph and see how we can solve them. The first one says calculate the maximum speed attained during the motion. So we want to look at the maximum speed attained in this journey. If you look at it, the bus accelerates from rest and got to point B. There is no further acceleration. So the maximum speed here is at point B or point C, which is the speed is given as BE. So if we can get the side BE or CF of this trapezium, then we are going to be obtaining the maximum speed because the maximum speed is at point B. So we are just going to consider triangle ABE and find the side BE, which is equal to our maximum speed. So for the first question, if we consider triangle ABE, the slope AB, which is the acceleration, is equals to BE, the velocity we are looking for, divided by AE, the time taken. So since we are looking for BE, we make BE subject of the formula, and we have that BE is equals to AB times AE. BE is the velocity we are looking for. So we can say that the maximum velocity is equals to AB is 2 times AE is 10. So the maximum velocity becomes 20 meters per second. That is for question 1. Now let's look at question 2. Question 2 says the total distance traveled. The total distance traveled for the entire journey is equal to the area of this trapezium you are seeing here. So if we find the area of this trapezium A, B, C, D, that gives us the total distance traveled. So question 2, total distance traveled, let's represent it as S. S is equals to the area of trapezium A, B, C, D. A, B, C, D. And the area of the trapezium is given as half the sum of the parallel sides. The sum of the parallel sides here are BC parallel to AD. So the sum of the parallel side times the perpendicular height, BE, which is also CF. And that is equal to the speed we calculated in number 1. So we are just going to put the figures inside this formula. So the distance traveled is equals to half times BC is 70, BC is 70. It's the same thing as EF because they are equal parallel sides. Plus AD. AD is the entire time taken, which is 10 plus 70, 80, plus 20, 100. So AD is 100 times BE, 20. BE is 20 from our previous calculation of number 1. So if we solve this further, we have that the distance is equals to half times 70 plus 100 is 170 times 20. And that will give us a total distance of 1,700 meters. So this is the answer to question 2. If you understood this, try this question 3, part of the question that says, what is the average speed for the whole journey? Please find the average speed for the whole journey and put your answer in the comment section. As a hint, the average speed of the whole journey is the same thing as the formula for speed. If you know the formula for speed, you should be able to calculate the average speed of the whole journey. Thank you very much for watching. Please like, share, and comment on this video. Share this video to others so that you keep encouraging us to make interesting content. Thank you.